One tropical system out in the West Pacific is putting an estimated 27.7 million people inside its tropical storm force wind field. That is one of the largest at-risk populations of any live hazard anywhere on the planet today, and it comes from a single storm that most people have never heard of. Here is the part that should get your attention. It has not reached Typhoon strength. It is still just a strengthening tropical storm, days from its peak. And that gap between how strong the wind is and how many people it threatens is the whole story. Everyone fixes on one number, the category. The wind speed at the eye. It is the first thing every forecast leads with, and it is the thing that decides whether a storm makes the news. So here is what does not add up. This system, Bavi, may never become a major typhoon. It might peak well short of the top of the scale. And yet the population sitting inside its winds already rivals what a Category 4 would threaten. How does a storm that stays lower on the scale reach more people than most of the strong ones ever do? Right now, that storm has a name. As of July 2nd, 2026, the US Joint Typhoon Warning Center is tracking it as 9W, and the Japan Meteorological Agency has just assigned it the name Bavi at 0100 UTC. The third-party trackers that flagged it under labels like 10 and 1026 are all pointing at the same circulation. The naming split is an artifact of how different agencies number these systems, not two different storms. It is one storm, and it is only now getting organized. Here is where it is. The center sits over the open Marshall Islands region, drifting northwest at around 7 knots, a slow, deliberate crawl that gives it time to feed. That slow motion matters, and we will come back to it, because a storm that lingers over warm water is a storm that keeps building. The forecast track carries it on that northwestward line under the steering of a ridge to its northeast, aimed generally toward the Mariana Islands. But do not let the still just a tropical storm framing fool you into thinking it has been harmless so far. Before this system was even a depression, its outer winds were already doing damage. Over the weekend, satellite data showed 30-knot winds along the southern and southeastern edge of the circulation, and those winds pushed onshore over Majuro in the Marshall Islands. They tore the roof off at least one church. They drove seawater up onto the coast and flooded low-lying ground. That is what a broad, still-forming disturbance managed before it had a name and before any category applied to it. Hold on to that detail, because it is the thread of this entire story. The winds that did the damage in Majuro were not near any eye. They were on the far outer edge of a circulation that had not yet tightened into a proper storm. The reach came first. The strength is still coming. And when you have a wind field this wide, the size of the footprint decides who gets hit long before the intensity does. That reach is exactly why the name matters, because right now this one storm is carrying 4 of them. Automated tracking feeds picked up the same swirl and labeled it Tropical Depression 10 and the tag 1026 that flagged this system to millions of people. A different feed called the same circulation Tropical Depression 9, off by 1 in its own internal count. The US Joint Typhoon Warning Center numbered it 9W in the West Pacific Basin, and the Japan Meteorological Agency, which holds naming authority for this part of the world, assigned it Bavi. 4 labels, and it is worth understanding why. Each agency keeps its own sequential count of the systems it tracks, and those counts do not line up. So the same storm picks up a different number depending on who is watching. It is a bookkeeping difference, not a scientific one. There is only one center of low pressure out there, and every one of those labels is pointing at it. And I want to be precise about the headline figure because it drives this whole video. That 27.7 million is a GDACS model estimate, a computer projection of how many people fall inside the forecast wind field, not a verified count of anyone yet affected. Move the track 50 kilometers, and that number can swing hard. Keep that in mind as we map where those people actually are. Here is what turns a moderate storm into a 28 million person problem, and it has almost nothing to do with the wind speed at the center. It is the width of the storm. The distance from the eye out to the edge where tropical storm force winds still blow. Bavi did not form in a typical spot. It spun up in the deep tropical monsoon trough, close to the equator, in the belt where the trade winds of both hemispheres converge. Storms born there tend to grow wide rather than tight. They pull in a broad, sprawling circulation from the start instead of winding down into a compact, ferocious core. And the forecast models agree on that character for this system. They show 9W developing an expansive wind field as it organizes a large storm, not a small, violent one. That single trait is what governs the exposure number. Think about what tropical storm force winds actually cover. In a small, intense storm, those damaging winds might reach out 60 or 80 kilometers from the center, a narrow ring of danger around a vicious eye. In a wide storm like this one, that same wind threshold can extend 2, 3, even 4 times farther. The total area swept by those winds grows with the square of that radius. Double the reach and you roughly quadruple the footprint. That is a lot more ocean and a lot more populated ground sitting inside the damaging winds. So when GDACS counts 27.7 million people at risk, it is not counting people near a Category 5i. It is counting everyone standing under that wide skirt of tropical storm force wind, most of them nowhere near the center. The peak intensity at the eye barely enters into it. The reach does. This is exactly why GDACS scores people rather than millibars. Its alert model does not ask only how low the central pressure drops or how fast the eye wall spins. It overlays the forecast wind field onto population data and asks a blunter question. How many human beings are standing inside these winds? A tight Category 3 over empty water can score lower than a broad tropical storm crossing a dense island chain. The pressure at the center tells you how hard the storm hits one point. The width tells you how many points it hits at once. And the people are the reason the width matters here. Bavi is aimed northwest, toward the Mariana Islands and the crowded corridor beyond. We will map that corridor next, because a wide wind field is only dangerous where it crosses somebody. Start with the water it is sitting over. The Western Pacific right now runs 28 to 30 degrees Celsius across the surface, and that warmth reaches down through a deep layer, not a thin skin. The storm can churn cold in a day. That is the fuel. Warm ocean evaporates into the storm, the vapor condenses in the towering clouds, and that release of heat is what drives the pressure down and the winds up. The upper atmosphere is cooperating too. Wind shear, the change in wind with height that can tear a young storm apart, is low along the forecast track. Warm deep water below, little shear above. That is the environment forecasters watch for, and 9W is sitting in the middle of it. Then there is the motion. The system is crawling northwest at around 7 knots, and the guidance slows it further in the 60-hour to 3-day window. A slow storm over warm water is a storm with time to organize a tight core, time to stack the whole heat engine into one column instead of smearing it across a moving track. That is the setup for a burst of rapid intensification, a stretch where the winds can climb sharply over a day or so as the storm consolidates. The forecast leans that way, though rapid intensification remains one of the harder things in this science to pin down in advance. Now hold that against what the GDACS orange level actually means, because it is easy to read a color and stop there. Orange is not a wind category. It is a humanitarian judgment, a severe event with the potential for serious impacts where some degree of international assistance may be needed. It is built from the forecast wind field laid over the population beneath it, and both of those inputs carry uncertainty. That is why the exposed count is so unstable. A tropical cyclone track forecast can be off by 50 kilometers at landfall, which is an ordinary, expected error. But shift a wind field 50 kilometers along a crowded island chain, and the population inside it can go from hundreds of thousands to nearly none, or the reverse. The same storm, the same strength, a small nudge in where it goes, and the 27.7 million becomes a different number entirely. The intensity is what the ocean is building. The exposure is what the track decides, and the track is not yet fixed. Here is what the wind field does once it reaches those people, and it is not what most of us picture. When a tropical cyclone kills, it usually kills with water, not wind. That is the finding that runs through decades of disaster records, and it reframes what 27.7 million people are actually exposed to. The clearest measure of it came in a study published in Nature in 2024. Researchers tracked United States mortality after tropical cyclones from 1930 to 2015 and found something the immediate death tolls miss entirely. The dying does not stop when the storm passes. It stretches on for as long as 15 years afterwards. The average US tropical cyclone, by their estimates, is followed by 7,000 to 11,000 excess deaths over that window. Deaths from disrupted healthcare, damaged infrastructure, displaced lives, ruined economies. The storm is the trigger. The long aftermath is where most of the toll accumulates. A separate body of work gets at how the water itself does the harm. One analysis covered more than 35 million deaths over 18 years and linked flooding to raised death rates across 4 categories at once: cardiovascular disease, infectious and parasitic disease, injuries, and respiratory disease. Flooding does not just drown people in the hour it arrives. It contaminates water, it breeds disease, it strains hearts and lungs, and it keeps killing for weeks after the water recedes. And it does not fall evenly. The same research found the sharpest increases in injury deaths among older people and among women. Those are the people least able to move fast when the water rises, least able to rebuild when it drains. Bury that inside a count of 27.7 million, and you can see the shape of who is most at risk under this particular wind field. So hold the two halves together. The intensity forecast tells you what the ocean is building. The exposure figure tells you how many people stand where the water will go. A moderate storm is not a small problem when its wide wind field crosses a crowded coast, because the wind is the warning and the water is what does the killing, long after the eye has moved on. There is a recent case that makes this concrete, and it is worth pausing on for a moment. In 2025, Typhoon Whiffer moved through the Western Pacific and never became a monster over the Philippines. It did not make a direct high-category landfall there. What it did was pull the southwest monsoon in behind it and pour that moisture over the islands for days. That combination, a passing storm feeding an already wet weather pattern, was enough to trigger widespread flooding across the country. The numbers from that event are the whole point. Whiffer, a system that would never have drawn a Category 5 headline over the Philippines, affected more than 9.5 million people there. 40 people were killed. Dozens more were injured, and several went missing. And it did all of that not with a violent eye wall crossing a city, but with water spread across a densely populated country. That is the case that answers the objection. If you judged Whiffer only by the strength at its centre, you would have filed it under storms that did not really threaten the Philippines directly. The people it reached tell a different story. 9.5 million exposed, 40 dead from a storm whose danger came from its water and its width over crowded ground, not from a record wind speed. Which brings the focus straight back to Bavi. The system tracking northwest toward the Marianas is being weighed the same way, not by how low its pressure drops, but by how many people sit inside its wind field and downstream of its rain. Whiffer showed what a lower category storm can do to millions when the geography lines up against them. The next question is where Bavi's wind field actually crosses, and who is standing under it. There is another case that matters here, because it happened over the exact islands now in the forecast cone. And only months ago, on the night of April 14th, 2026, Super Typhoon Sinlaku moved its eye directly over Saipan and Tinian. This was a Category 4 storm with maximum sustained winds estimated near 150 miles per hour. And crucially, it slowed down. As it crossed the islands, its forward speed dropped to around 5 miles per hour, which meant the destructive winds and rain did not pass in an hour. They sat on Saipan, Tinian, Rota, and Guam, hour after hour. The storm left 43,000 people across the Mariana Islands without power. It had already tracked over Chuuk in the Federated States of Micronesia, where it killed 1 person and left a fisher missing at sea. That is the lesson the Marianas learned in April. A storm that slows and lingers does far more damage than the same storm passing quickly, because every additional hour is more wind loading on structures and more rain feeding the floods. Which is exactly the concern with the system approaching now. Bavi is forecast to slow as it nears the islands, and its wind field is expected to broaden the same combination that made Sinlaku so punishing over the same ground. So here is what to watch over the coming days, because the 27.7 million figure is going to move, and the direction it moves tells you where the danger is heading. Watch the wind field radius first, ahead of the peak wind estimate. A storm that intensifies its core but stays compact threatens far fewer people than one that spreads its tropical storm. Force winds outward across 200, 300 kilometers of ocean. The exposure count is driven by width more than by the number at the center, so the radius is the figure that matters most. Watch the track split. Some model runs thread Bavi through the northern Marianas, carrying its wind field directly over Saipan, Tinian, and Rota. Others keep the center east of the island chain entirely, which would spare the populated islands the worst of it. Those are two very different outcomes for the people underneath, and the models have not yet converged. Until they do, no single forecast graphic deserves your full trust. And watch whether the forecast rapid intensification burst actually fires. Bavi is expected to slow as it enters a highly favourable environment, and forecasters expect it to strengthen quickly during that slowdown. If that burst happens while the storm is near the islands, it stacks the two dangerous ingredients together: more intensity and more lingering time over the same ground. The GDACS exposure number ties all three of these together. Every time the track nudges, every time the wind field widens or tightens, that figure will climb or fall. When it jumps, it means the forecast just steered more people into the storm's reach. That is the single number to keep your eye on, because it moves before the storm does. The most likely outcome is a storm of moderate intensity, not a record-breaking eye wall, not a Category 5 headline, but the size of the population underneath it does not move with the category. That gap is the whole story. The win number can stay unremarkable while the number of people at risk stays enormous. So keep both figures in front of you. A storm this wide, over ground this crowded, is dangerous whether or not its centre ever earns a dramatic label. 27.7 million people sit inside one wind field right now, and the track that decides which of them get hit could still shift by 50 kilometers in either direction. We will be tracking this system as the forecast sharpens